In this series of videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the definition and use of both subroutines and functions. In this series of videos, we'll be covering topics which are common to both the PowerBasic Windows compiler and the PowerBasic console compiler. In order to do this, I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the console compiler. There are three basic functions in this common display library. There's prep output, log, and wait. The prepare output function takes a console name as a parameter, an X and a Y start coordinates, and optional rows and columns. Since this code is designed to work regardless of whether you have the console or the Windows compiler, we're using a conditional if statement, which is handled at compile time, to test if we're actually inside the console compiler or not. So you'll see in here there's an if def pbcc32, which if that's set up, we are in the console compiler, and it will prepare the functions accordingly. If we're in the Windows compiler, the same three functions will be prepared, but internally they'll be slightly different. So for the console compiler, we're using a standard console window, and for the Windows compiler, we're using a text window. For developers starting out in programming, the difference between a subroutine and a function can be confusing. In computer programming, a subroutine is generally defined as a sequence of program instructions that perform a specific task which are packaged as a unit. This definition also works for functions. The main difference between a function and a subroutine is that a function returns a value, whereas a subroutine does not. If we look at the basic structure of the code we have here, these are three functions. Two of these functions take parameters. The prep output function takes a total of 5 parameters, 1 string and 4 numbers. The log function takes a single string parameter. What we're going to do today is add a few more functions and subroutines to demonstrate how they're used. If we create a variable within our main function here, we can actually demonstrate the use of a subroutine. Now we've given this particular string some data, we're now going to create a subroutine that will take that data and process it. Now, a subroutine starts with the word sub and ends with nsub. We have specified that the subroutine will take one single parameter. Note that the name of the parameter itself does not have to match the name of the variable being passed. It will be referred to as this name within the subroutine. Now, by default, all parameters in PowerBasic are passed by reference. If you pass a parameter by reference, it means the variable from where this parameter came can be updated. If we change the value of the parameter, and then we'll call our function to output it to our console. If we run that code now, we will see that the original value of the string is output, plus the additional information is put on screen. Now, to prove that once the subroutine ends, the original variable has been updated, if we output to our log and output our original variable, and then we run that again, you'll see that the value is exactly the same. So in calling our subroutine with strValue, the string has been passed to the subroutine has updated it, and since we're passing by reference, then the value in the original variable is passed back to the original calling routine. Now if you wish your subroutine not to update the original variable, you can use by value. Passing it by value means that any update done to the string will not be passed back to the original routine. So if we run this now, we will see that the subroutine has in fact added more data to the string. The original variable has not been updated. This is important if you're actually passing information to a subroutine or even a function which you do not wish to update the original variable. If you leave out the by ref or by value, the system assumes by ref, so any change made to the variable will be updated. If we were to create a function, it would insist on a value being passed back by the function. Now this can be of any variable type you wish. If we make it a string, we can then create a local variable . Now what we've done here is we are taking in the value from the original calling routine. So we're taking in this string here as a parameter to our function. We're then taking the value within that string, putting it into a local string, a local variable. We're then appending the extra information to our string, and we're printing out the value of that to the console. Additionally, what you can do, you can pass back the value as a return from the function. Now, if we substitute this, at the moment we're not actually making any use of the return value, so if we run that now, the value is as expected. What we can do is we could take this entire line and paste it in there. What we're doing here is we're calling one function, and the parameter of that function is the return from a second function. This is the primary use for a function. Since a function will return a value, this function is accepting the value coming out of this function. If we run that now, you will get the data as expected. Functions are very useful in this case in that you can actually simplify your programming, where if you have a large complicated series of steps to go through, rather than create one large subroutine to actually do all the work, you can break the work down into smaller logical units and perform them within functions. And these functions can then take a parameter, or more than one parameter, and return a value. It's a matter of personal preference how you actually structure your code. Some people use functions almost exclusively, some people use subroutines extensively, and only a few functions. It depends on how you wish to program. In PowerBasic, there is a special procedure called a Fastproc. This is slightly different from all the other ones you would actually use. In a fast procedure is a highly simplified form of a sub or function, which executes much faster than either of the two normal, fully featured functions and subroutines. However, it does allow only a maximum of 2 bival long arguments, and may optionally return a long result. This particular procedure is only used if you wish to process something very, very quickly. This completes this short introduction to subroutines and functions. Thank you for watching.